The next speaker will be Mr. H.R. Madhusudana. Mr. H.R. Madhusudana completed his MSc in Physics from Kuvempu University and a B.Ed from R.V. Teachers College, Bengaluru. He worked as a teacher in a CBSE school for 9 years before joining the Jawaharlal Nehru Planetarium in 1995. He retired in 2023 and is continuing at JNP as a visiting faculty. He was primarily involved in planning, coordinating, and teaching in all the non-formal education programs for students and teachers at all levels since its inception in 1995. In addition to academic work, he's also involved in various stages of producing planetarium shows such as scripting, visualizing, and music. He has worked on developing a science park at the planetarium as well as in vast majority of their outreach activities. Please welcome Mr. Madhusudan.
Thank you very much for the kind introduction. And at the outset, I would like to thank the IIIT-B and in particular Professor Jaya Nair for this opportunity to be here with you and speak about a person and his association with the planetarium, one who I admire enormously. And also I had the good fortune of working with him alongside on a number of educational programs at the planetarium for a very long time. So I thank you all for this opportunity. And I would also like to extend my thanks to Professor Saraswati Vishweshwara. Professor Vishweshwara was, I'll be quoting him a lot during this informal presentation because after all, we are talking about him and his work. So it is poetic justice that we pick his way of thinking through some anecdotes and quotes attributed to him. So he would always say that in a presentation, one should have a good beginning and a good ending and keep the two as close to one another as possible. And half of that Professor Jaya Nair has already taken care of by keeping the beginning and ending close. I have about, say, another 15-20 minutes left. And the problem is to have a good beginning and, of course, a good ending. So what can be a better beginning for me to begin with how Professor Vishweshwara began at the planetarium here. And this is one of the earliest photographs of Professor C.V. Vishweshwara at the planetarium. And though the planetarium started in 1989, my association with planetarium on a formal basis was from 95 onwards. But informally, I had been involved in some of the educational activities of the planetarium that Professor C.V. Vishweshwara started right from 1992. So this is a visual that was created by noted artist Shri B.G. Gujarappa. I think this was done when Professor C.V. Vishweshwara turned 65, and there were a few people privy to this making, and one of the persons about whom I'll be referring a bit later, Professor Bala Iyer, was one of them. So you will notice that this particular visualization of Professor C.V. Vishweshwara's personality. On the right-hand side, you have on a handpost, base camp, black hole hunt, and there are a few things to be started and which have not yet been started. So base camp was one of the earliest programs that Professor C.V. Vishweshwara started here at the planetarium, in which children could come and do hands-on activities. And those days, about 3 decades back, such activities were very, very few in any part of the country. And definitely in Bangalore, it was not very popular. So he started this. And the black hole hunt refers to a series of talks that Professor C.V. Vishweshwara gave to undergraduate students, which was in a way the beginning of a very, very popular program called Research Education Advancement Program, or REAP in short. And REAP has become a full-fledged popular program among undergraduate students who wish to take up a career in physics, especially. But now it has also become more broad-based into biological sciences as well. So, if this visual has to be redone by Shri B.G. Gujarappa, and the hand post has to be uh, complete with all the activities that he started and which have been nurtured, nourished, and continue to this day. The hand post would have to be a separate poster by itself, because that is the diversity of the activities that he thought about, started, and fortunately that legacy has been continued to this day. Um, So this is one of the last public talks that Professor C.V. Vishweshwara gave at MES College, Bangalore. This visual has been taken from that. Um, uh, and between the first visual where you saw Professor Vishweshwara at the office table at Planetarium and one of his last public appearances here, I would like to recount some of the greatest things that he has done for science education in general, uh, and especially at the planetarium. So this is a photograph from his graduation day. Um, he graduated from University of Mysore and then went on to do PhD under Professor Charles Misner. So Charles Misner is a very well-known physicist from University of Maryland, and Professor Vishweshwara was his student there. And he worked on the stability of what we today call black holes. This is one of the seminal contributions of Professor C.V. Vishweshwara to black hole physics and general relativity in general. I'm not highly competent to talk about his professional work involving his research, but from what I have heard directly from him and later on from many others who worked with him, this particular problem, that is to show that that the black holes exist, that had been theoretically done. But then to show that once the black hole has been formed, it can be stable for a long time. At least it should be stable for astronomical timescales for one to study them and characterize them. And Professor Vishweshwara instilled that confidence through his work that black holes indeed can be stable for long times, even when they are perturbed under linear perturbations. So that was a PhD work that involved Professor C.V. Vishweshwara, and it is very, very important to show that they are very stable. Because what is the use of having an object which would have a very transient existence, transient even on human time scales measured? So, in his inimitable style, he had this particular cartoon. He was a great cartoonist. Perhaps uh, had he not been famous for his work in general relativity, he would have been equally famous for being a cartoonist, making such wonderful cartoons, which brought about the seriousness of science in his inimitable humorous way. So here in this cartoon, you see that there is a black hole which has been perturbed by the sneezing of an ant. So the sneezing of an ant is just a metaphor there. What he meant to say was that no matter what kind of perturbation, a black hole had to be stable. And Professor Vishweshwara's work established very firmly that black holes are indeed stable. So the other very important work that Professor C.V. Vishweshwara did was about this particular characterization that black holes have no hair, which means to say that if you have to characterize one particular type of black hole called Schwarzschild black hole, then just having information about its mass is sufficient. All other descriptions of the black hole would follow from the mass that we would have determined. Then just for the sake of completeness, for the audience who are out there, While black holes have been very popularly defined as an object in which the speed of the escape velocity would be so high that even light cannot escape. While it is very catchy as a popular phrase, Professor Vishweshwara would always be unhappy that it does not do justice to exactly what the black hole does. So he would always prefer to represent this black hole as some kind of a one-way membrane, wherein one could actually cross the membrane one way, and once you have crossed the membrane, there is no way of crossing the membrane again a second time. So it was some kind of a wavefront which would be crossed by an observer exactly once. Um, there are many notable things that Professor C.V. Vishweshwara worked during his professional research time. But I would like to highlight on one particular aspect which is so much in the news today, and which is very, very important for us, especially in the context of what astronomers call multi-messenger astronomy. Because for a long time, light was the only messenger that brought information about the happenings in the universe. So you had to study the spectrum of in different forms to infer about what is happening in the astrophysical systems. But then gravitational waves, which uh, came to be directly detected about a decade back, thanks to Professor C.V. Vishweshwara's seminal work. I'll come to that in a short minute. So this particular work has shown that universe can be studied not only through electromagnetic waves like light, but they can also be studied through gravitational waves. And the kind of information that you get from astrophysical phenomena involving gravitational waves can be very different from what electromagnetic waves bring. So put together, you would have a more comprehensive understanding of astrophysical phenomena or astrophysical objects. But then, while Einstein's theory of gravitation or general theory of relativity predicted the presence of gravitational waves, production of gravitational waves, neither Einstein was very confident that they could exist. There was a doubt in his mind. And nor did many of the scientists of his time seriously believe that something like gravitational waves could exist. So, for almost 4 decades after Einstein's formulation of the theory of general theory of relativity, and showing that gravitational waves could indeed could possibly be present, there are still many scientists who doubted. So it is against this the scenario that Professor C.V. Vishweshwara's research career started. And when you start your research career on a problem which not many people believe, and then you go on to establish that these things can indeed happen, that's a very, very big leap in understanding that is always there. And it is a huge contribution to the growth and development of that particular domain of knowledge. So what Professor C.V. Vishweshwara did in 1970 was to produce a very short paper which was published in a highly respected scientific journal, Nature. And in this, he showed that when a black hole is perturbed by a Gaussian packet, by some kind of you could throw anything at a static black hole, and then he showed that the black hole would momentarily deform and regain its form, and in the process, they would emanate what are known as gravitational waves. But then we would know that theoretically gravitational waves are possible. But if you have to detect one, what is the kind of signature that you look for? Because you need to know what you look for in order to build a detector. The principle on which a detector is built very much depends upon our understanding of the characteristics of the object that we want to detect. So in this case, the gravitational waves. So he showed that a gravitational wave produced by a perturbed black hole would be something like what you would see on the left-hand side of the screen. It was predicted through his paper in 1970. And what LIGO, the Laser Interferometry Gravitational Wave Observatory, detected in 2016 That is shown on the right hand side of the screen. Uh, uh, and you can see the correlation between uh, what was predicted and what was finally detected. So it is precisely because we know the signature of a of a gravitational wave coming from a perturbed black hole that a detector could be not only built, and also any computer's algorithm that goes into detecting the gravitational waves uh, in a uh, in a haystack of a lot of noise coming from the universe, then the signature has to be very, very precise. And this is how it was detected. And when this was done, the entire uh, community of astrophysicists in particular uh, were highly appreciative of Professor C.V. Vishweshwara's work, and it came to be recognized globally that his work played a big role in the detection of gravitational waves. So this particular picture that you are seeing on the screen was taken on the day that on the day LIGO announced the direct detection of gravitational waves, and Professor Vishweshwara was there at IUCAA in Pune, along with many other luminary astrophysicists, and he was invited there. Uh, but then he said that though he had some kind of hunch that something big was happening on that day, he really did not know that this was the announcement that was coming up. And he was extremely elated that in his own lifetime, he could actually see one of his great predictions come true, even though it was after almost 4.5 decades of his theoretical work. That only goes to show how difficult the technology is, how difficult technology is that goes into detecting gravitational waves. So this is the kind of research that he did. As a sample, I'm giving you the two of the most significant problems related to general relativity were solved by Professor C.V. Vishweshwara. And for a man of this stature to come down to a small institution like Jawaharlal Nehru Planetarium, become its founding director in 1989, is by itself a very big thing, uh, because the kind of work that he would have had to do as the director of the planetarium would have been very trivial compared to the kind of creative research that he did. But then he was extremely clear about one thing, that his own research, while it would affect some of the research in his area and researchers in his area, he wanted to build a body of um, researchers who would continue that legacy and contribute to society, contribute to scientific progress over a long period of time. So he had a very ambitious plan, even as he took over as the founding director of the planetarium, because I did meet him even before I joined Planetarium. Um, I met him in 1989 on the day of inauguration of the Planetarium. The first show that he had scripted, I happened to watch and later have a chat with him. He was already putting the show that he had produced on the back burner. He said there are more things to be done in the planetarium, and one of the most important things was to liberate planetarium from planets. I'm quoting him verbatim. He said, "I want to liberate planetarium from planets." By this, what he meant was to show that planetarium should become the nucleus of science education and not merely be restricted to astronomy, planets and stars and so on. And again, he was very, very strong in his belief that to produce good astronomers, good astrophysicists and cosmologists, it was absolutely important that uh, that students had a very good ground in basic sciences. And again, for a person who was a trained theoretical physicist, he had immense respect for experimental science. So much so that he made sure that every activity of the planetarium that he evinced had an experimental component in that. And not surprisingly, the first program that I got involved with him in the planetarium before even I joined was in a program called Science in Action. Okay, and this uh, Science in Action was a 3-day exhibition where children would actually set up experiments which were functional. So those were the days when yeah, science experiments were mostly confined to making static models out of thermocol and things of that kind. You know, you make a nuclear reactor and show how it works, of that kind. There were not many experiments that really demonstrated science uh, in action. So Professor Vishweshwara came up with this title, Science in Action, so that he could show the things happening out there and children could actually see the phenomena unfolding right in front of their eyes. Okay. And that was the first program that he started. And um, uh, he was uh, a great communicator of science, whether it was giving a technical talk on his subject to uh, subject experts, or it was talking about his own work to general public or to students. He had a distinct style of communicating research and science, which he also integrated that with the education programs of the planetarium. So just to give you a sample of uh, the rich variety of talent that he had, he would make these kinds of cartoons. Uh, while at one stage it would be very humorous, it was also conveying the science in a very serious manner. Especially, he believed that if an institution like planetarium should become an institution that would disseminate a scientific temper, no amount of uh, no amount of having programs to dispel scientific temper would actually help us dispel scientific temper. The only antidote for superstition. So the only way you can dispel superstition was to teach good science. So he would have a various techniques of doing that, and one way would be to come up with such wonderful cartoons, which would be um, not only conveying um, the science part of it or the lack of it, but also do it in a very humorous way, which would not offend people. So that was one of the great things that he had. So this is just another one. I'm running out of time already, so I have to skip some of these things a bit quickly. So here he says uh, the grocer he says he can't help it because it's part of the missing mass in the universe. That was a problem that was often talked about in the 1990s. So this is how it okay. This is one of the cartoons which I have enormously enjoyed, and I can't break into a big laugh whenever I see this. The professor says, in order to explain the unobserved dark matter, unobserved dark energy, unobservable extra dimensions, and unobservable bubble universes, I have derived an invisible equation. So this is how he would actually uh, take off on some of the claims which if he felt that they were not in order. But he would do it in a very humorous, subtle manner. So now I would like to spend next uh, 5 to 7 minutes or so on Professor Vishweshwara's work at the planetarium, especially related to popularization and popularization of science and science education. So, like I mentioned to you right at the beginning, when he took over as the founding director of the planetarium, he was absolutely clear that this place must become a nucleus of science education. And he would actually not venture to introduce astronomy, astrophysics much early in one's a student's science education career. It would come much later because he says he also believed that in order to be good at astronomy, astrophysics, first of all, one should be good at basic sciences. Therefore, the thrust was on cementing the principles of physics, principles of mathematics, and so on. And like I told you, he would place much emphasis on experimental science. And the other thing that he would emphasize always was the problem solving. And he would always tell this. that you are only as good as the last problem that you have solved. So these are all one-liners which he must have told me some 20, 25 years back at the beginning of my career at the planetarium. But if I remember vividly, even to this day, and I keep passing on this in his name to thousands of other students, it's only because of the great impact that it has had on many people like me as a teacher. Okay, so he would emphasize the importance of problem solving through such a catchy one liner that you're only as good as the last problem you solved. The next one, if you're unable to solve, it shows that there is a glitch in your understanding of the concept. So, in the process of trying to solve the problem, you actually learn to uh, hone your understanding of the concept better and refine it. So, uh, the popularization part, he wrote several scripts for the planetarium show, which have become some kind of a template for people like me. Um, there would be a lot of science, and at the same time, there would be mythology, there would be art, there would be anecdotes, there would be richness of the Indian music, and so on. So these are all some of the planetarium shows that Professor C.V. Vishweshwar has scripted. And on the right-hand side, some of the artwork that he produced as part of these programs are what you see. He worked with one Sri Chandranath Acharya, and B.G. Gupjarappa. Even to this day, are an integral part of our planetarium show production. They come up with such wonderful pieces of artwork. Okay, so like I told you, any amount of programs that you have to dispel superstition would be not so effective. But you have some cartoons like this, and in a very subtle manner, you inject at the right time. The science behind that would be amply conveyed to people. So there you see a pregnant lady who is being pushed into a dark room because there is an eclipse. Okay. Then there would be an introduction to an introduction to Milky Way galaxy would invariably through the mythological stories like Gangavatarana, and Chandranath would come up with such wonderful works of art. Then, as I told you, this is a glimpse of science in action that Professor Vishweshwara started, and to this day, it has become an annual affair, and it's immensely popular program. Thousands of school children, college students, teachers come here, and what it has done to the planetarium activities is that over the last 3 decades, we have a huge bank of working experiments. So virtually any concept in physics at any level of teaching, we have experiments to demonstrate and to show the phenomena. So here you see that he's in rapt attention listening to children. This was another great thing that I admired about him, that he would never ask children questions that the children themselves would feel uh, difficult to answer. He would just ask them, and if they did not have an answer, he would gently nudge and then give them hints, or he would just tell if somebody like me standing besides say that maybe they will help you. And he gave a lot of attention to the students, and the students would not know the greatness of the man to whom they were explaining. They would naively explain Newton's laws of motion to the person who spent all his lifetime on Newtonian gravity and Einsteinian gravity. That was that. And the other thing that he started was a science park, uh, which is there for all visitors to see today. It started on a very modest scale with a few exhibits in 1997-98, and within about 15-20 years, we have put together more than 50 working exhibits in the planetarium, encompassing various concepts in physics. Thousands of children who come to the planetarium shows, they work with these exhibits, they play around, and they also get a lot of scientific content. So this is another thing that he started. This is a glimpse of the science park today. And coming to the educational programs, um, he started a program called, not in the same order, It's called SEED. SEED is an acronym for Science Education in Early Development. So children as young as 8 to 10 years would come to the planetarium for about 10 days. They would be indulging in hands-on activities and set up some activities, experiments, without worrying too much about understanding the working principles. So the working principles would be discussed at the bare minimum, but the thrust would be more on helping children to work with their hands and do these models that would actually work the way they are supposed to work. Okay, these are pictures from this is a picture from one of our latest one where uh, children of the same age group are working on a model aeroplane. So this legacy has continued. And then the other program that he had in mind was for uh, high school children. It was called Science Over the Weekends or Science on Weekends. So while in Seed, the thrust was basically on getting them introduced to science. The SO program was a little more serious, where children would actually be part of some kind of lecture-based, discussion-based coursework, and in addition, they would also be exposed to various kinds of experimental activities. So this is one of the courses in which they learned about brain, and the human brain was actually brought into the classroom, and the faculty from Center for Neurosciences in IISc, Dr. Aditya Murthy and his students, they are explaining to them about the various parts of the brain and how it works. So no amount of computer simulation would bring the kind of joy that looking at the real brain would bring. So this was the thing that he always emphasized. This is also an integral part of the way Science Over Weekends is done. So we had a seed and we had a sow, and here are children working in the laboratory. So demonstration experiments that we have in a program like science exhibitions, they would only be an introduction, an invitation to come to do science. But the actual doing science happens in the laboratory when they try to quantify the phenomena. So without quantification, experiments do not have a valid place in science. So we have a moderate a physics lab in the planetarium where children can do open-ended experiments like you see here. And in the very early days, I must uh, express my gratitude through Professor C.V. Vishweshwara for Dr. Margaret Biswas, who was chiefly responsible for these high school sessions. So we used to teach high school classes together. It was real fun in doing that. And so one of the greatest contributions of Professor Vishweshwar to the planetarium, in addition to bringing these programs, is to bring the right kind of people to the right programs. And Dr. Margaret Biswas is one of them. And so here she is when she recently visited the planetarium. And this is how typically we have a classroom where children are engaged over the weekends. So here is one professor, Ranjini Vishwanatha from JNCA-SR. She was a student of Planetarium undergraduate program, which I'm coming to in a minute just now. So the happy thing is that, like her, many of the students who came through this undergraduate program have now become faculty at the program that they were part of as students. So the third program, which is at the pinnacle of our educational programs, is called REAP, or the Research Education Advancement Program. So you have the SO, you have the SEED, and you have the REAP. These are all wonderful acronyms that Professor C.V. Vishweshwara himself came up with. Um, and just to paraphrase that, the title of my today's talk is about Professor C.V. Vishweshwara, Sowing the Seeds of Research. So I have borrowed from these three for my title of the talk today. So in Research Education Advancement Program, students of BSc or MSc and even engineering students who are keen on having a career in physics, they come here over the weekends. It's a 3-year course, very rigorous, but done in a way that it breaks the shackles of a formal approach of a college or a university. There is much freedom. There is a lot of scope for creative thinking, and needless to say, all this REAP program um, draws heavily on both the theory as well as experiments, and we are immensely helped by a huge number of faculty from various research institutes who come and teach here. And here is Professor Vishweshwara teaching himself in one of the programs uh, in the early days. Then there is Professor Bala Iyer at the top. I mentioned about him earlier. So he is one of the pillars of this educational programs of the planetarium. So while C.V. Vishweshwara conceptualized and he was very clear about how these programs should be run, and in the early days when we did not have any kind of publicity and people who could understand why they have to do this kind of a program, Professor Bala Iyer was one who staunchly supported this program, and for a long time he has been teaching at the planetarium in all its undergraduate programs and some other programs, and we owe a lot to him. And people have been trained by him and Professor Lokanathan that you see at the bottom of the picture of the screen. And in recent times, there have been uh, people like Professor Arun Mangalam from Indian Institute of Astrophysics who come year after year after year and who have been teaching in REAP, inspiring students to do research. Many of them have gone on to become teachers at different levels, and they have established themselves as very, very good teachers. So mainly because they have been exposed to some wonderful pedagogical way of teaching themselves under people like Professor Vishweshwara, Bala Iyer, Lokanathan sir, Arun Mangalam sir. The list is very long. I don't have time to list all of them. My apologies for the names that I have left out. So REAP would have activities of this kind. Um, and later, with the success in REAP, it was also extended to BioREAP, which is the biology counterpart of physics. Again, we have been immensely helped by a number of scientists from biological sciences in Indian Institute of Science, NCBS, and so on. In fact, Professor Saraswati Vishweshwara herself has been one of the early contributors to this. Dr. Rene Borges and Professor M.R.N. Murthy has been there. You see Professor M.R.N. Murthy teaching a set of students. Yeah, the legacy goes on. And of all the programs that we have had, it goes like a pyramid. We have the popularization program at the base of the pyramid, then workshops and exhibitions, then the educational program, and right at the pinnacle, we have the REAP program. So as the pyramid tapers, the programs become more and more serious and more rigorous and more challenging to students. And as we would expect, there would be less number of students who would survive at the highest point. But then Professor Vishweshwara would always say that numbers do not matter as long as we produce quality students out of these programs. So I would like to end my talk about Professor Vishweshwara's association with Planetarium and its programs. Like I told you, he brought all these luminaries to Planetarium, and many of them came here because of him. And here you see Dr. H. Narasimhaya at the top left, and then Professor Lokanathan, then Dr. Raja Ramanna, and then P.C. Vaidya, who visited Planetarium. And one of the proudest things that he would, Professor Vishweshwara would show around were the laboratories in the Planetarium. So for a person who was so much grounded in theoretical physics, his emphasis on experimental science is something that I have come to appreciate. And this is Professor Roy Kerr of Kerr Black Holes fame. And this is the gallery of students who have gone out of our REAP program, who have become PhD scholars, and some of them have come back to teach in the planetarium programs. This is a partial list of the entire gallery of students have gone. And I think on this note, I would like to end by saying that some of these students have come back as teachers of REAP. Professor Vijay Kumar Krishnamurthy, who is a faculty at ICTS. So you see him explaining conic sections as a student of BSc long ago. So now he is a faculty here. Professor Ranjani Vishwanatha, then Jayant Vasankare, who is a wonderful teacher at Azim Premji University. So this is all the legacy that we have. So this is another way in which you could contribute to research. One, by your own research during um, your say some part of your career, and at some other part of the career you spend time in really nurturing and nourishing others who would become potentially very good researchers. So that has been the contribution of Professor C.V. Vishweshwara to science education scenario in and around Bangalore at least. But all these students have gone to other parts of the world, so they continue the same spirit of doing science. And on this happy note, I conclude, and I thank once again the hosts, and I end with my apologies for having taken a few minutes more. Uh, Thank you very much.
Thank you so much, Sri Madhusudana. It has been a great informative talk to understand what Professor C.V. Vishweshwara has done. And especially the cartoons were a bright spot, I have to say, and everybody else would also admit that. So thank you so much.